Hello, everyone. This is the lecture for section 7.1, parametric equations. So in this section, we're making a big jump in the textbook. We're going from chapter 4 to chapter 7. We're going to learn a new representation of how to graph certain things mathematically, okay? The very first one that we're going to be doing today is the parametric equations, okay? Like I said, it's a different way of graphing it, right? We're actually going to be adding in an additional variable, okay? That's what makes it different than what we are regularly seeing, okay? So the first thing I want to do, right, is before we move on, is just define what a parametric equation is. So here's the definition, right? If x and y are continuous functions, right, on a variable t over an interval y, or I, sorry, then x is now a function of t and y being a function of t. Those are what we call parametric equations, right? And the t variable is what we call the parameter, okay? The set of points, we're still going to look at them as x, y's, right? But now they're defined by a separate variable t, okay? And these are what we call parametric curves, okay? So let me show you guys how this sort of works out to begin with, yeah? So I've got two examples here, okay? Let's say we had these two parametric equations right here, right? X of t is equal to t and y of t is equal to t squared, right? So when x of t is, or sorry, when t is -2, right, we'll have x of -2 is equal to -2. Simple enough, right? But now when we want to do y of -2, right? That's going to be -2 squared, right? And that's 4. So we have an x and a y now. So our x is going to be -2. Our y is going to be 4. Okay, let's go ahead and do t equal 1 now, right? So x of -1, right, is going to be -1. Pretty simple, right? But let's go ahead now and do y of -1. That's going to be -1 squared, and that is 1. So now -1, 1. That's my next point. Okay, let's go ahead and do the next one, right? X of 0 is 0. We're good. Y of 0 is going to be 0 squared, which is still 0. That's good. 0, comma 0. Okay, let's go ahead and do t equal 1. Hopefully you guys are seeing what's happening already, right? That's 1. Y of 1 is 1 squared. That's still 1. So 1, comma 1. And then when we do 2, right? X of 2, that's still 2. And then y of 2, right, is 2 squared. That's 4. So 2 comma 4 is our point there. Okay. So now I'm going to try to graph these points, right? So if you take a look, right, -2 comma 4, -2 comma 4, that's like about right there. -1 comma 1, 0, 1, and 2 comma 4, right? And if you go back one more, let's say we went back and did -3 and +3, right? -3 would be 9, and +3 would also be 9. So hopefully you guys see what's happening here, right? The graph of this is actually, let me actually do it in a thicker blue. There we go. Yeah, I'm trying here. That doesn't look too good. Let's try it again, huh? So dropping, connect there, connect there, connect there, go through there, go through there, up that way. There we go, right? Okay. So the graph of this is actually your parabola, just a good old y equal x squared, right? But now what we have here is a specific sort of the new representation, the parametric representation. This is the parametric equations for a parabola, right? Now, what I want everybody to notice is this, that as we go downward, right, our t value sort of increases in that direction, right? And it gives us certain points, right? What that means on the graph, right, is that our t values are doing this. They're going down that way, right? And then on the way up, they're going this way, Okay, and that's why this is one of the good things about parametric equations is that it's given us a direction. Whenever we graph something parametrically, it gives us a particular direction that we need to go. Okay, and it's defined by those t values. Okay, let me try one more. Okay, for cosine t and y of t is for sine t. Okay, so I'm going to start the same way, right? X of 0 is 4 times cosine of 0, right? And cosine of 0 is 1, right? So this is now going to be just 4. Y of 0, right, is going to be 4 sine of 0, right? And sine of 0 is 0. So it's going to be 4 times 0 is 0. So this point is going to be 4 comma 0. Okay, let's go ahead and do t equal pi over 4. So x of pi over 4 is 4 cosine of pi over 4, right? And if you guys remember, pi over 4, the cosine of it is the root 2 over 2, right? So root 2 over 2, and this reduces to 2 root 2, right? Y sub of pi over 4, 4, and not cosine, sine, of pi over 4, right? Same thing, 4 times root 2 over 2, and this is 2 root 2. So my point here is 2 root 2 2 root 2. Okay, let's move on. X of pi over 2, 4 cosine of pi over 2. So cosine of pi over 2 this time, that's 0, right? So it's going to be 4 times 0 is equal to 0, right? Y of pi over 2, right, is 4 sine of pi over 2. Okay, sine of pi over 2 this time, this is 1. So this is going to be 4 times 1. So that's 4. So my coordinate now is 0 comma 4. Okay, when t is 3 pi over 4, 3 pi over 4, you have your unit circle on you, that would help. Cosine of 3 pi over 4, 4 times root 2 over 2, 2 root 2. And I forgot something in this case. In this case, the cosine of that is negative, right? So negative, negative. Okay. Do the same thing for y. Y of 3 pi over 4 is 4 sine 3 pi over 4. 4 times, in this case, sine is positive, right? So this is still root 2 over 2. So this is 2 root 2. Okay, so our x and y here are negative 2 root 2, comma 2 root 2. Okay, and now the last one, let's go ahead and do pi. X of pi is equal to 4 cosine of pi, or cosine of pi this time, right? That's going to be negative 1, so negative 1. So negative 4 y of pi is equal to 4 sine of pi, which is 4. Sine of pi this time is 0. So 0. Whoops, not 4, 0. Okay, so then we get the next coordinate up, negative 4 comma 0. Okay, so now let's go ahead and graph these points, yeah? So At t is equal to 0, we had this point, 4 comma 0, right? So that's going to be way over here. Okay. Next point up, 2 root 2 comma 2 root 2. So that's about 2.8 something, right? So I'm going to put it like around here. And then the next point's going to be same thing right here. So it looks like it's going to be something around here, which makes sense. That's supposed to be 45 degrees, right? Okay. The next point, 0 comma 4, right up there, right? The next point is negative, right? So now I got to go negative 2.8 something, and then positive 2.8 something on the y. So about right there, maybe, right? And then the last point, negative 4 comma 0, so right here. So hopefully you guys see what's going on here. Whoa. Whoa. You have no idea how hard it is to draw on this thing. There we go. There we go. I think I might got it. I might have it. Whoa. All right. With the exception of this little piece right here, right? We do have it, right? And if you take a notice, right? As time keeps going, right? It's going in this direction. Hopefully everybody sees that, right? And it just turns out that this is the top half of a circle. So this is the parametric representation. This representation that's right here, right, is the parametric representation for a circle of radius 4. So if we kept going with the time more than, if we let the t go farther than pi, right, then we'd be able to get the whole entire circle if we wanted to. Okay, so now that we know what this is looking like, right, I'm going to go ahead and try to graph this for you. Let me go and choose Desmos. There we go. Okay, so I'm going to do a double screen here. Okay. Let's go ahead and do the first one first, huh? So let's say we wanted to graph those two, right? So I'm going to go ahead and put down a coordinate, right? And I'm just going to do t comma t squared. So notice how I set this up. My x's were the x variable, right? My x is my x of t, and my y is my y of t, right? So that's it. I've got it graphed. Let me actually make this a little bigger so you guys can see. There we go, right? Now, at the moment, I just have it from 0 to 1, right? So it's not very interesting. It gives me that little piece right there, right? But I wanted it, I did it from -2 to +2. So I could change the t value where I want it to start and where I want it to stop. I'm going to do -2 here and 2 there. And now I've got the parabola that I just graphed. Okay. And now I can make this go even farther. So instead of doing it from -2 to -2 or +2, I can do -10 to +10, right? And now I've got like a big, huge parabola. Okay. Let's move on to the next one. So my x is going to be 4 cosine t, right? So I'm going to go ahead and delete all that. And it's going to be 4 cosine of t, parentheses are your friend, 4 sine of t, right? And there we go. It gave me my circle. Okay, and it is the circle from radius 4. So now, what I did here, I did from 0 to pi, right? So I get to go ahead and change this if I wanted to. I'm going to just say it started from 0, right? And do it just to pi. And there's my semicircle. There's my half circle that I drew out, okay? So there in itself is how to graph these, right? So let me get rid of this. So now that you guys have an idea of how to graph these parametric equations, let me center that a little bit. There we go. Okay, I want you guys to try it out. So I want you guys to at least find 2 different points, right? Just calculate them out, right? And then I want you guys to use Desmos to try to graph these, to tell me which ones they are, okay? And I'll at least give you this much. Groups 1 and 3, those representations actually are of the same thing, okay? And then same thing for groups 2 and 4. So to double check that both of these representations that you're graphing are correct, right? Try both of them out, okay? Even though they're not yours, try both of them out, okay? So now what I want you guys to notice is this, that because of this quick check, right? I've just told you that 1 and 3 are the same graph and 2 and 4 are the same graph. So what turns out happening when you have parametric equations is that you don't have a unique representation for the same curve. That is, you can write two sets of parametric equations that draw the same thing. Okay. You can have two sets of parametric equations that draw the same thing. So your representations now are not unique. Okay. Now, just like I mentioned before, right? In the problems before up here in the examples, because we have a new variable now, t, right? And it's crawling from negative infinity to positive infinity, right? There's only one direction that thing can go, right? As it goes from sort of negative infinity to positive infinity, right? It gives us a direction. That's what these arrows are for. If you guys see these arrows, right? This type of representation, parametric equations, gives you a direction, okay? And that's pretty cool, okay? And you'll see why in one of the examples down below, okay? So now, there's gotta be a way though, okay, of what's called eliminating the parameter. Suppose we had two parametric equations, right? Parametric equations are great, right? But sometimes you might want to just eliminate it. You don't want, there's no need for that extra variable t, right? So how do you eliminate the said parameter, right? So basically turning the two sets of parametric equations back into a y equals, a function of x. Does that make sense? So that's what we're going to do now. I'm just going to show you guys how to eliminate the parameter, and it's sort of how you think it would be. You're gonna just try to eliminate the t variable somehow, some way. Okay. So let me go ahead and eliminate the parameter here. It's actually pretty simple. I'm gonna do it with this one. The overall idea is you're gonna solve for that variable t, right? And then try to substitute it into your other equation, your y, okay? So in this case, what I'm gonna do is I'm gonna grab that x of t, right? Get a nice expression for t equals to stuff with x in it and then substitute it into my y, okay? So I'm gonna first start with this. I'm gonna go ahead and grab this and I'm gonna say x is equal to 1 over 2t minus 3, right? Which tells me that 2t minus 3 is equal to 1 over x. And if I solve this out, t is going to be equal to 1 over x plus 3 divided by 2. 2. Okay? So this is the expression that I'm going to use. This right here is going to be the expression that I'm going to use to eliminate the parameter. Okay, so hopefully at the end, I'm going to have just y equal to stuff in x. Okay, and that's the next thing I'm going to do. I'm going to grab this and I'm going to plug it into y of t, right? So then I'm going to say y is equal to 2t minus 3. Now t is this, right? So it's going to be 2 times 1 over 3, 1 over x, getting ahead of myself, 1 over x plus 3 over 2 minus 3 all over 2, my t, 1 over x plus 3 over 2 minus 2 plus 2. Okay, and we're off to the races at this point. So I want everybody to notice this. So my 2 on the bottom and my 2 here cancel, my 2 on the bottom and my 2 here cancel. So this reduces to 1 over x plus 3 minus 3 on top divided by 1 over 3, whoops, 1 over x, haha, x plus 3 minus 2 plus 2. Okay, I'm going to keep going. The plus 3 and the minus 3 on top, they cancel, right? And then the plus 3 and the minus 2 on the bottom, they sort of subtract away. So I get left with 1 over x on top divided by, it's going to be 1 over x plus 1 on the bottom, right? Plus 2. And this is going to be 1 over x over, right? 1 plus x over x plus 2. Okay. And if you do this math right, you end up getting 1 over x, whoops, not x plus 1. Let me keep it the notation as it is. 1 plus x plus 2. So my y is equal to my f of x, which is now that. So what am I saying here? So what I did is this. I grabbed my parametric equations, right? This parametric equation, this set of parametric equations that I just put down on the screen here, right? Do something, right? That set of parametric equations is equivalent to me graphing this thing right here. Okay. Now, you guys are probably like, well, sure, whatever. I don't believe you, right? So let's go ahead and graph it out, right? So let's go ahead and cancel that away, right? I'm going to set up the parametric equation just like normal, right? So 1 divided by 2t minus 3, right? Comma 2t minus 3 divided by 2t minus 2, right? Plus 2. So, and right now I have it from 0 to 1. I want to actually make it a little longer. Let's do negative 10 to 10, just so that we get a nice drawing out of this, right? There we go. So my graph is supposed to be this. My parametric equation is supposed to be this right here. Okay. Now let's go ahead and graph our f of x, right? F of x is equal to 1 divided by x plus 1. Let me do 1 plus x. 1 plus x plus 2. If you guys take a look, right, it is the same equation. Just one is done parametrically and one is done explicitly using y equal f of x. Okay. Both are the exact same graph, right? Okay, so I'm going to go ahead and snip this out. I'm going to plop it in our notes so you guys can refer to it too. So boom. I'm going to zoom out a little bit and then paste it in. Make it a little smaller. There we go. Boom. Now we know what it looks like. All right. There we go. That's our parametric equation, right? So notice what happened here, right? We have now two representations, right? We can have a y equal f of x, right, where it is explicitly defined, right? And now we have parametric equations where we can represent a curve, right, with a time t, with a variable t, and it's usually called a time, right? You'll see why the reason why that is down when you do the lecture questions, okay? All right. So now, these are the exact two equations that you guys were messing with from before, right? I've given you all sort of like in the first quick check, I let you guys all sort of graph them, correct? Right. Now I want you to eliminate the parameter, okay? And just like in this one, just like in our example, right? If you eliminate the parameter, you should get a function f of x, which is exactly the same as the parametric representation of your function. Okay, so same thing here, right? If you eliminate the parameter, right, and if you do it appropriately and you graph both, then you should get the same graph. Okay, so that's just a quick double check. All right, cool. And I believe that is it. That is what comes up next is lecture questions. So I want you guys to try these out. If you have any questions, please stop by my office hours or my Friday hours, and we can knock them out. Okay. Besides that, happy studying.